So now we're given a VI curve, and the problem is what is the equivalent potential of the ion channels, and we all know the equilibrium potential is a steady state potential basically. So equilibrium potential, in other words steady state, means that the number of ions that's going through the membrane needs to be zero, so that it means the I is zero, and when the I is zero, well, we see that the V is equal to about 30 millivolt. So that's the equilibrium potential of this ion channel. The core conductance at the V equal negative 10 millivolt. So this is the equilibrium potential. Core conductance is a slope from this equilibrium potential, and then the point of our interest, So at negative 10 is about here, which is negative 1, and this is this point. So we can simply calculate the slope pretty easily just using Pythagorean theorem kind of thing. So it will be this is 30, so like rise over run. So the chain, this is like at negative 1 over 40 millivolt will be the core conductance for B. And what is the ratio of the intracellular and extracellular concentration of the ion? So we have this equation given. So ratio, we know that this is 58, but we gotta put a 30 in here. So this is 30. So 30 equals 58 log 10 outside concentration over inside concentration. So if you do the calculation, so 30 millivolt equal to 58 millivolt log 10 outside over inside. You can kind of like move it around so that 30 over 58 is equal to log 10 XOXI. That means that 10 to the power of XOXI is equal to 30 over 58. And so if you do the math, you can get X over Xi. And for the last question, is the current inward or outward rectified? We can see that the dominant slope here is over here. This when the slope is the highest, and that is when the voltage is negative. Or not voltage, the current is negative, which means that's like the dominant, like the current, right? Because that's when the slope is the most dominant. And conventionally in electrophysiology, negative current is associated, or I mean, is classified as the inward current. So this is inward rectified. So this question we're given VI curve again, and the problem is asking what is the conductance ratio between K and the potassium and the sodium, both at the rest and upon stimulus. So we can just like get conductance, which is the slope of this curve, pretty easily. Just do the math from this point of where their point on the V voltage axis when the current is zero, because that's the equilibrium potential. And then get a slope from that point to any point that's like convenient to get this slope, since it's this flat line. If you do that, you get a resting potential, or the conductance at rest of potassium and sodium. We get these numbers, and as stimulus we get these, which is just different lines. And then what's the resting potential of the sensory neurons? So a resting potential is just the this is just asking the, sorry. So at the problem A, you do that, and then you just get it's asking the ratio of the potassium and sodium. So you just put 0.0025 over 0.00083, and you get like 3. And then if you do the same thing over here, you get like 0.25 for stimulus. So that was problem A. And then resting potential is just Goldman equation. And I'll review this later.